Good day everyone! In this video, our group will be tackling two of our first lessons we learned this first quarter. We will be providing you explanations and examples for you, our viewer, to recollect our past lessons in general mathematics. Firstly, we will be recalling ordered pairs. So what are ordered pairs? In simple terms, ordered pairs are a pair of objects. But in mathematical terms, ordered pairs are composed of x coordinates and y coordinates. Why do we need ordered pairs? Ordered pairs are important when it comes to the Cartesian plate since they help us plot points for us to have a better understanding of our graph. They can also make graphing a whole lot easier. Without ordered pairs, we will have a hard time graphing our equation. We will also have a hard time defining if the given is a function or not. Let's talk about the composition of ordered pairs. As I've said before, ordered pairs can consist of x values and y values. Our x values can be seen as the domain and can be also called as our abscissa, while our y values can be seen as our range and can be also called as our ordinate. Ordered pairs can also be identified with four different correspondences. We have one-to-one, one-to-many, many-to-many, and lastly, many-to-one. The one-to-one correspondence is only applied when our domain has only one relation with our range. One-to-many is when one of our domain has multiple relations with our range. Many-to-many happens when our domain and ranges have multiple relations with each other. And many-to-one when multiple of our domains have one relation with a single range. These correspondences help us determine if the given is a function or not. If the ordered pairs have one-to-one and many-to-one correspondences, it will be automatically classified as a function. But if the ordered pairs have many-to-many and one-to-many correspondences, it is not considered as a function. Here are some examples of ordered pairs.
Many-to-many is an example of not a function. In many-to-many, domain and range ordered pairs connects to each other more than twice. The key to this is if two or more set of ordered pairs connects and create more relation, then it is considered as many-to-many. In example number 1, domain has only two sets that connects to three sets of range, so it is considered as many-to-many. In example number 2, all of the set of ordered pairs connects to each other, so it is considered as many-to-many. The sets of domain in example number 2 has all the connection to all sets of range. As you can see, car has three connection to range. Car connects to Honda, Toyota, and Mitsubishi, like motor, truck, and scooter. So example number 2 has many connection, and it is considered as many-to-many.
In this example, we're gonna determine if it is an ordered pairs. In our domain, we have the name students Easy, Jazz, Mariah, and Zion. And in our range is their age, 16, 17, and 18. Let's say Easy is 17, Jazz is 16, Mariah is also 17, and Zion is 18. We name it many-to-one because our domain is Easy and Mariah is the same age. If we're going to write it in an ordered pair, Jazz is 16, Easy is 17, Mariah is 17, and Zion is 18. And that's our example of ordered pairs many-to-one.
Greetings everyone! Today, I will be discussing about the vertical line test, or in other terms, the VLT, which was one of the first lessons we learned about in this first quarter. The vertical line test is related and connected to our first topic, which is all about functions and relations. The vertical line test is used whether we want to determine if the given graph of an equation is a function or not. Doing this test is rather simple. Just draw a vertical line through the graph of relations, and if the line touches only one point, then it is considered as a function. However, if the line touches two or more points in the graph, it is not a function. There are different types of functions, and those are linear, constant, absolute value, quadratic, square root, cubic, cube root, rational, and many more. And remember that If the relation has one-to-one and many-to-one correspondences, it is not a function. While if it has one-to-many and many-to-many correspondences, it is not a function. Here are some examples on how to use vertical line test.
Hi guys, I'm going to teach you about the vertical line test. First, we need to make a table for us to identify if it's a function or not. The given table shows that the given set of points are function because it is one-to-one, and one-to-one is an example of function. Next, we need to graph it. As you can see, it proves that there is one x value in every y value. It is possible to visually determine if a line in the plane correctly represents the graph of a function. Once the vertical line intersects the point, it is a function. In the second example, you can see in the table that the given set of points is an example of one-to-many, and one-to-many is an example of not function. A one-to-many relation exists when one element in the domain graphs to the multiple elements in the range. It is an example of not function because if the vertical line intersects two or more points, then it's not a function.
In this example of vertical line test, we are given by 2, 4, 3, 6, 4, 8, and 5, 10. Now, we are going to plot or point the givens. 2, 4, 3, 6, 4, 8, and lastly, 5, 10. There are no identical inputs for the first ordered pair, as can be seen. It means the vertical lines passing through the graph of the given ordered pairs will pass through at exactly one point on the graphical sketch. The relations pass the vertical line test and, as a result, are a function.
That's all for today's lesson. Thank you so much for listening. Our group hopes that we successfully talked about and help you recall the past lessons in general mathematics. All of the things we talked about in this video will surely help you in the future, so don't doubt yourself. See you again next time.